my time? Okay. That means I can't play any more games on my phone. Hi guys. I'm Mariah. I think you're gonna have to actually stop airplane.
Oh, okay. Yeah, let me jump off.
Do it. And then it should be smart enough to
There we go.
do some prevent that. Does it work? Do my buttons work? Is this on? Oh, it's not on. Now it's on. My buttons, okay, they do. Cool. So I'm Mariah. I work here. Thank you for coming. I hope you enjoyed this talk. I'll be yelling at you today. So at Weave, I like to call myself an ML engineer or data engineer, just because I like to get my hands in every single time they say machine learning. I just like jump in and don't let them do it themselves. I myself host several meetups. There's 5 meetups that we have here at Weave monthly. They're in the evening. I'm also organizing a Go conference that will be taking place in May. I'm really excited about that. And most importantly, I do have a dog. So this picture is the only picture where my dog's looking at the camera. He's a little tiny one. The other one's his cousin who passed away recently. But it's a beautiful picture of my dog. Today I'm going to be talking a lot about Google AI. Google AI is basically a big name that Google has given to its suite of products that provide machine learning functionality. That is everything from APIs that you can hit, models that they have trained, and open source notebooks that you can use for iterating on models, training them yourself, different versions of storage from BigQuery to Firebase, cloud file storage, anything you can imagine, and different cloud instances you can use for training on your model. Everything from your CPU up to a beautiful, giant, large TPU with its amazing computing power. At Weave, we have a very important product focus of moving fast. We used to say move fast and break things, but we don't like it when things break because then people complain. So we just like to move fast and nothing ever breaks. But in the idea of moving fast, AI is not fast moving. It's a very expensive, very slow, iterative process to be able to gather data, train your own models, build pipelines, do all of those things. So we've made very conscious decisions to take advantage of the products that Google has that are very out of the box, easy to use, easy to ship, to leverage AI tools, ML tools in our product without having to worry about a huge ROI or a huge overhead cost to get to that state. So that's a lot about what I'm going to be talking about today. Is the services Google provides, and a lot of it is going to be based off of the Weave use case, things that we've used in our product to gain these benefits. I have played around with more things. Feel free to ask questions throughout. I like things to be as informal as possible. It makes me less nervous. So going forward, we're going to start about NLP. This is not neuro-linguistic processing. This is a natural language. Neuro-linguistic programming, is that what I said it was yesterday? Neuro-linguistic programming? Yeah. Neuro-linguistic programming is Winter Soldier. That is neuro-linguistic programming. The other NLP is natural language processing, which is the idea that you can take text data and convert it into usable structured data, gain insights from it, and then leverage it in your product. Google has lots of platforms for this. As you can see, I've put the symbols for both Auto, ML's NLP, and their NLP APIs. Google has like 10,000 logos that I downloaded and stuck where I could. Something really common, very important, is the idea of speech to text, that you could take a raw speech file and convert it into reasonable text that you can then leverage in other parts of your product. We provide a phone service for most of the small businesses that use our product. And we want to be able to leverage the speech to text part of our phone service, whether that be voicemails that they can read as text messages, whether it is transcriptions of voice memos that they can store in the app, or transcription of our sales calls that we can then run NLP statistics on to gain data about what are the best sales tactics, you know, general customer sentiment, things like that. Can all be gained from the text, from speech to text. So there's going to be a lot of live demos today. So we'll start with our first one. First one is Google's speech to text API. Do we not want this there? Can I get rid of that? Okay. So, and I need to make this big enough for people to see.
Right, you were a courageous presenter.
This is the 4th time I've given this talk. The demos work.
I always test them in advance.
I'm just, yeah, by the time you've done it this many times, it's like, they haven't failed yet. So, yet. I tried them last night. Oh, I forgot it. Dang it! I didn't source that crap. Oops. That way they actually use my secrets. Now we can do it. Now it'll work. Sorry, I don't want anyone to have my secrets, so I've hidden them. Now you can't access my, anyway. So I'm using gRPC. All of their APIs are interfaced over gRPC or a regular REST API. I like gRPC and I like Go, so I've written all of my examples in Go using gRPC. Just so you know, you can use any language with gRPC or with REST. You're not limited to that. I just did what was comfortable for me, and it works well. And for Weave, for any of the POCs I'm doing, our whole stack's in Go, so it made sense to do a POC in Go that we could then translate. So here is just a gRPC server I have set up for their speech-to-text model. There's a little bit of config that you do with it that I think is important to note. When you're doing a speech-to-text, you can select certain things. I have an uncoding unspecified because it is not a WAV file, it's an MP3, so you can select WAV or unspecified. Those are the options. I also notice I have a phone call model because I'm doing, my example is a sales call. You can choose other things. This just will highlight certain vocabulary that will be more common, or certain speech patterns that are more common in certain contexts of speaking. You would speak differently on the phone than you do in a face-to-face conversation than you do talking to your Google Home. Yes, Troy.
Can I ask a question?
Yes, Troy.
I'm just wondering, what other kinds of models are there, and where would you find that list?
On the API website. So while we're here, see, Troy, this is why we do live demos. You can go to the Google Cloud NLP API. And here, they have all of the quick start guides. And then if you actually go into the gRPC specs, I believe I was looking in the Python one, they have a list. So you do have to do a little bit of digging to get that list, but I did find a phone call. But this is where you would start and then go forward. Anyway, also right here, another important thing to notice is the sampling hertz rate. There are 2 common ones, 8,000 and 16,000. That's basically saying, how much of this soundbite do I want in my snippet that it's analyzing? If you want it bigger, you would put 8,000. If you want a smaller snippet, it would be 16. I did not see a difference. So I figured going with the smaller one for less time on the API didn't, it didn't make a difference. So I have my server running, hopefully. So I'm gonna go ahead and run the client. This takes a minute. And so, no, it's not server, it's client. And then I will explain what it does. So this is pretty simple. I have the server running locally on port 3030. I'm using gRPC insecure because this is just an example. If I cared, I could be more specific. And notice that I am using a proto buff here to format my message, and that I'm actually pulling the phone call from a bucket on Google Cloud Store. I don't have anything locally. I'm just pulling it off across and formatting it in proto, sending it to this file, and it's hitting the endpoint running their speech model. And when we get it back, which does take a minute, and as long as this is still running, we should be good. See, this one just takes a long time and I always get worried. But it's like a 20-minute phone call, so that's why it takes a long time. If I had a 5 minutes texting, it would work better. And what I'm gonna print out is I'm gonna just print out, oh, there it is, see, it always works. A big concatenated glob of text with an actual average of the confidence. Generally speaking, you do not want to take averages of confidence. You wanna know how confident we are in each speech to text, but that doesn't make an awesome demo. So here's our phone call. It's really great. You can see there's a lot of Weave specific data in here. OfficeMate is a product we integrate with. So they talk a lot about OfficeMate. It's I don't remember if it's dental or optical, but it's one of those CRMs used in that field. Most of it makes a whole lot of sense. There's some things that are weird. We have it's Lisa DeLiz at Gmail. Obviously, it didn't realize that that was an email, so it kind of messed up there. But overall, for the most part, we got an average of a 0.71 confidence. So it's pretty intelligible, good enough to put out for someone and they'd be like, oh, somebody generated this, but I can get the gist of what it's saying. Not too bad for an API. So going forward. Another thing that we do is sentiment analysis. We actually have our own model that we've trained and deployed for analysis because we have some certain boundings that are very specific for our use case. What we do is we have a service that sends appointment reminders for people. And we don't want them to reply with a capital yes or a capital C. We want them to make it more casual. So they can respond with any positive or any negative, or actually there's a couple more options that they can respond with, such as I want to reschedule, or I want to cancel, or I want to, or I will make it. So we have about 5 different things that they can respond with. So we'll take anything from the thumbs up emoji and say, yeah, they're coming, to an F off, which means they really don't want us to talk to them anymore and we will not message them again because that was a wrong number. But that's very specific to Weave, which is why we have chosen to do our own model there. Google does have a sentiment analysis API endpoint, which actually works really well. I wanted to show it to you. This one's easier because you do not have to set up a server, you just hit it. Again, you can use REST, and I'm using gRPC because I think it's funner. Is funner a word, or is it more fun?
More fun, but it's fun. It's funner when you say it's fun.
We're going with funner. So I have a sentence right here. So I'm saying the sentence is, I love ice cream and I hate those dang mosquitoes. And we're gonna see how Google managed it. Google's gonna take that, divide it into sentences and tell me if it's positive or negative on a scale from 0 to 1, or sorry, -1 to 1. Anything less than 0 is negative sentiment. Anything greater than 0 is positive sentiment. And from the 0 to 1 is by how much. A full 1 means it's super positive. A full -1 is basically an F off, which I have never tried, but somebody could.
I can help you out with that.
So we will hit this up, and this one's a lot quicker because it's not a 20-minute soundbite. So we have right here in our terminal a nice little thing. We say, I love ice cream. It's in the English language. It's a 0.9, almost full sentiment of love. Mosquitoes, that's a -0.3. So I don't know why hate and dang and 3 exclamation points don't make it worse, but I know if you add, but we've tested this before. The more exclamation points you add, the madder it gets. And I'm gonna add, if you put stupid, just add more words. Stupid, ugly, fat. I don't know if it's gonna be like, that doesn't make any
Now you're
sense.
body shaming mosquitoes.
I am. I hate them. I don't know why they even exist. But you can see by adding that, I really do think the 17 exclamation points is what makes it so negative. But Google recognizes the difference of those words and those exclamation points. And so for a first pass of sentiment, that's really great. You can go forward and do a whole bunch of just little analyses there to and leverage it in your product. Really easy to run. So Oh, guys, my team showed up. Hi, team.
Hey.
I'm glad you could come support me. GoogleVision. GoogleVision is really cool. GoogleVision basically is anything that you could do with an image or video, Google wants to help you with. These are things from static image files to full videos to image recognition, image classification, not safe for work material. Anything you can imagine is available through GoogleVision. I was calling it Google CV for a long time, and then Pablo corrected me. Pablo's sitting back there. It's GoogleVision. That's what the API endpoint is called, so don't use Google CV, it's GoogleVision. At Weave, like I said, there's a whole ton of use cases, but at Weave, we do a lot of phone number porting. And so part of that is we have to be able to identify, actually, I might be lying about this use case, but just roll with me. We have to identify where the phone is, so we will get bills, we will identify the address, pull it off, confirm an address, and then be able to port the phone. We have a nice little option in our app where people can just take a picture with their phone, it does that detection of that text, and then we parse that text field and get the appropriate information. You can do this with any kind of object detection. You can detect for dogs, you can do bounding boxes. Bounding boxes are generally how self-driving cars work. They don't care what the object is, they just want to make sure they don't hit something. If they were really smart, they would put the grandma over the pole, but I don't think they're quite there yet. So I wanted to run through just a quick demo. So like I said, I'm hosting a conference. So here I have a text file of just a LinkedIn thread, at the screenshot from my phone, a bunch of words, text about my conference, people resharing it. So I took this photo and I went and I threw it in this API endpoint. Again, using gRPC, just because that's the best. So I made a new client. I said, here's my file, take my file, annotate it, and then I told it, okay, you can pull the text out, you can get each text object, you can analyze the text, you can do a whole bunch of things, but for this purpose, I just wanted to highlight each text object. So, as you can see, it highlighted every single text object that is available on that image. There is no object of text that is not, it did not highlight as an individual object, which is actually quite impressive. So it has like 50, I don't remember, it was like 19 objects that it found of text. It did not do images, it did not do anything else, just the text part. And each text is just basically a string that you can then analyze in itself. So the string LTE would be different than the string justinshakespeare.second, different than the actual Go West conference box, which is really cool. And we've had a lot of success with it. Pablo did it. Good job, Pablo, for doing that hard task. But just a super cool use case, and that was actually really fun to do and pull those out. Next one. There's a whole bunch more. I really can't like cover everything, but just to highlight a few, Google has pipelines for labeling your data. You can do automatic labeling. They have Dialogflow, which allows you to create chatbots or actions for your Google Home. So if you want to say, Google, I'm hungry, and then it automatically pulls up a DoorDash menu for you, you can program that in Dialogflow. You have audio, ML video. This does actual analysis of video. I'm pretty sure they stole something from YouTube in the process to do that analysis, but you know, they're friends. You have AutoML tables. That's where it actually takes a table of data, pulls out the features that are important for you, and will pull a model that it thinks will help you. It does really cool feature analysis, saying this one's more important than the other feature, and then it pulls an accuracy of your model after that. You have cloud inference, which is actually pulling statistics off of your cloud deployments and saying, hey, you need to spin up another instance. Hey, you're actually really low. You can cut them down, all kinds of things there. AutoML translation does exactly what you think it does, detects a language and then translates it into another one. And then, of course, BigQuery, which is amazing for storing and querying on data. I actually wanted to talk about BigQuery a little bit. I don't know how many of you are familiar with BigQuery setup, but it's a very common data warehouse that's hosted on GCP. It's a columnar store, which allows you for large-scale queries, over different things, and it's really not expensive to use. We have stuff that is being stored in BigQuery. We don't run that many queries across it because we weren't that aware of how the column store worked, and we weren't super intentional when storing our time series data in it. But it's still super fun to leverage and to experiment with. And the best part about it is BigQuery has a whole bunch of open source data that you can go look at. If you want to get into ML, do some experiments on it, you want to start getting your hands deep in data analysis, you can pull any of these open source data things from it and just start doing queries, seeing what's there, experimenting with it, and like I said, leverage the amazing product that is BigQuery. I always like to find fun ones, like the crimes in Chicago, diseases. There is a deadly disease table in there, and I think it's fascinating. I just never can find it.
Did you correlate it to the years Tinder was active?
Oh, no. They also have like the Stack Overflow one. Does that say synthetic patient data? We don't care about fake patients. Oh, but we could do San Francisco film locations. That's fun. So if you pull that out, you can actually, there's a smart thing in here that's, that will, so if you, I like to do this. It says, what are the most famous trees in San Francisco? Gives you a question, and they're like, okay, we'll generate a query for you. So you pull it up, nice thing in there. Look at that nice, crazy query for you to find those streets. It's pulling it from just one table or a second table, joining it, grouping it, ordering and descending. Let's run that. Okay, so we have tree 224,627 is on Buena Vista Avenue, and it was in Looking Season, episode 2.
That's hilarious.
The Last Black Man in San Francisco has a famous tree in it. I didn't even, this is a great data set. Black Man in San Francisco has a lot of trees. Anyway, we have 46 famous trees. And you can do other things in here. Basically, any SQL you want to run, you can look at. They have this visualization thing that I honestly haven't messed around with that much. But visualization is really a good way to leverage. See, I'm not going to do this right now because this is live and I haven't messed with it. But visualization is a good tool for explaining to the higher ups why data is important. So the fact that you can do that right in BigQuery off of your data that you just queried and explored allows you to make meaningful visualizations and kind of explain why data is important, because that's the one thing nobody ever understands, is why data is important. So BigQuery is a great tool. You can leverage AutoML tables on your BigQuery tables themselves, and it'll pull things out for you. So it's great because it has all of those integrations right in there.
Are you going to talk about BQML, Ryan?
What?
Are you going to talk about BQML?
I am not. BQML is different than AutoML tables, but it does allow you to, from what I understand, and I haven't used it, it allows you to do AutoML, not AutoML, it allows you to automate your machine learning training and deployment process based on your BigQuery tables. This is based on updates, based on features, based on whatever you want. You can do that machine learning and then deploy straight off of it. That is how it works, right?
Data sets that it'll actually look at so they're consistent, so you can keep training it. And do
Oh, see, and it cares about data stability too. So it'll say this is good data, this is not good data, and do a difference on that to make sure that you're constantly progressing towards a better, cleaner data, better models, and better versions of your service. Any other comments on BigQML?
Yeah, I mean, the initial algorithms were just regression based, but there's a whole suite of new algorithms. I'd have to check what's out of.
Honestly, every 6 months, Google releases a new, they take out of alpha or out of beta a whole new suite of tools. It's constantly growing, and they're all really great. I think there's only one more thing I wanted to hit on, and that is the Google Colab notebooks. So this is not actually, well, it is hosted in Google Cloud, but it does not require you to have a GCP account. These are free for everyone, open source, and they're notebooks that basically live in your Google Drive. They're cached in your Google Drive, and you can share across your network, so within Weave, we have a Google Drive, G Suite account, so I can share my notebook with anyone in Weave. For my personal drive, I can share it with anybody. I've seen a lot of people actually put collab links in GitHub, so you can then go interact with the code live on Collab. They have GCP instances, not GCP, yeah, GPU instances, so you can train on a GPU. You can also hook it up to your local machine if you have an NVIDIA, whatever, and they're really cool. I wanted to just show you a quick demo. We're gonna be using these at an upcoming hack day we're having next week. Where we have an ML guild within Weave. These are all people who are interested in learning machine learning. We've organized a hack day to tackle a problem that one of our teams has. And so we're going to be using collab notebooks to split into groups of 3 and work together collaboratively on a machine learning problem. Here, I just have a quick Python notebook open. It's not very big, is it? But as you can see, I have quirky mode turned on, so there are dogs running across the top. I also like that it's dark mode. But it's pretty simple. I can run my bash commands. I actually have the content in my Google Drive that I can pull right out by mounting it. And I just run basic Python analysis on it. I have it pulled into a data frame. I can do the basic statistic analysis of the data frame. And then I'm actually doing a most common words distribution, just a quick frequency distribution on that text. See what's common, and as we expect, stop words are the most common. And like I said, I can share this with anyone. It's super cool. Anybody who's used to working in Jupyter notebooks, this is just a Jupyter notebook. It's just really easy to share. You don't have it hosted on your local. It's hosted on the cloud and stored in your Google Drive. I'm making everybody use them from now on at Weave. I think they have hosted notebooks in GCP, and I prefer these just because they're easier to share. You just share just like you would with a Google Docs. You just make it shareable and send them a link, and then they can open it and change it. Works the exact same way as Google Docs, Google Slides, all of Google's things. Oh, and you can save it to GitHub. So if you do have a working project that you've iterated on and you want to then make it so you can deploy it, you can cache it to GitHub and then go further with that way. You wouldn't be able to upload it from GitHub and then, I mean, you can have it synced to GitHub. It's just a lot harder. I would recommend just saving it to your drive and caching your final product to your GitHub that you can then move forward to productionize. But that's pretty much all I got. All of my examples are on my GitHub. We can make these slides available. If you have any other questions, I'd be happy to take them. Go ahead.
I've got a question. You showed an example where there was dialogue and you did some image to text after, right? How is that, does that come back in JSON, and how does it, what information does it have in there that would help you identify, some of the errors? I saw that, one of the sentences was split into 2 separate objects, and that would need to be combined if you're doing some processing. And then secondly, being able to identify what fields you're really trying to capture out.
So on this one, this is actually has 2 objects, so I can move it. Oh, go back. So if I were to edit this, where?
Yeah, so that Taylor
So
con.
this is actually 2 image objects.
Right.
So we just created a second image object around the name.
I see.
So so what I did was I pulled out, so this, I'm using gRPC, so it's returning it in a protobuf. If I was using REST, then it would return it in JSON.
Okay.
And there's like about 17 layers of nesting to pull out the information you want.
Yeah.
So they have, the first layer includes the text. And so each text object, so every single box is a unique text object that it'll pull out and put there. What I did was I went a couple layers down and I pulled out the bounding boxes. And those are just corners.
Right.
And then so then what I did was I just put that on my image and cut out what I wanted. I just mask. I just masked the image to pull out the bounding boxes themselves. So it did not return the image like that. It returned the vertices of the bounding box. But yeah, so it just created a second image. So it's more of a double object. it did pull out the second object in itself. So you could do a quick dedupe if that was necessary. On this one, as you can see, a lot of it is duplicated. So if I didn't want that text there, if I didn't care about duplications, I could remove duplications and then do.
What would you use? Is there anything in particular that Google has to, identify what the fields are? Like, oh, this is a name field, and this
Yes.
is their comment.
So
Parse, take this and to put it in a
yes,
structure.
so they do have that, and I always forget what the word is. But it's very common to pull out the parts of speech. So they do analyses on parts of speech, sentence structure, that's all available through the API. I just didn't do an example with it, and you can still pull that out and do, it's not called syntax, but it's basically a syntactic analysis of it.
Yeah.
I always forget the word, I'll remember it tomorrow at 9 o'clock. And you can do that, and you can leverage other tools that they have available from the API to run things on them. I know we just do regex for parsing internally. You can also pull this out, put it in a notebook, and then if you're using a Colab notebook, you can do something with Spacey or NLTK, and then leverage those NLP tools to do the same thing.
Okay.
Other questions? Now? I feel like that was a lot of information sometimes because I have so many different use cases, but they were all really easy to implement. Every single one of my demos took me probably 2 hours. The only one that took me 2 hours was the image one. It was doing the stupid masking. That one was just a long time. But that was not Google's. The masking was me.
I'll ask you an opinion question. So in your opinion, what's the boundary between using automated tools like this versus building your own models, doing experimental research, machine learning, doing research in machine learning, where you're building out a lot more customization?
I think that what I'm calling out-of-the-box tools are a good middle step. For example, say you don't have a lot of data, or your data's not labeled, or your data's just not in a good state. You can take this, put this into your product, and then take the steps you need to clean your data, and then start researching and iterating on it, right? We're all gonna have a use case that we can then take, and we can do a transfer learning algorithm on, or we can do our own custom model on, or research that then better fits our needs. But there's a difference, like I said, if you wanna be quick and you wanna leverage these fast, the APIs are where you wanna go. And if you want better results, then take those APIs and then you can start labeling your data off of them. Then you can start or classifying them or organizing it based on that. You can use these as labels, and then you have your other data that is different, and then you can start training your model going forward based on the results of this or the data you're getting afterward or other things. I think it's more of a speed. I think custom models will always perform a better result because they are based on a use case in your specific data. But these are just super easy to implement. And like, just because Google has so much data, unless you're gonna do some kind of a transfer learning, they're very, very, very efficient and accurate in that way. Go ahead.
I saw that GCP has a human labeling service.
They do.
Have you used that? Do you have any?
I have not.
Okay.
We haven't really, I haven't had a need to do that. I mean, sorry, there is always a need for labeling, but we haven't identified a use case where we would want to employ that here. And for personal projects, I don't, generally speaking, go out of my way to find to have somebody else do my labeling. I'm trying to save money on personal projects, not spend it. I haven't used it.
What's been your favorite use case that you've solved with ML?
My favorite use case?
One favorite use case.
Yeah, I can tell you. And you're saying that I've implemented it or theoretically thought about it.
You've got a model that works, whatever you want to say.
I've only implemented MLP stuff.
Okay.
So we've done usually they're classification problems where we're using text data as a feature as opposed to numeric data. So I've done word embeddings to get classification models, whether that be address classification. We're doing one here at Weave where we have basically appointment statuses we want to map that does that. And I've done some personal stuff as well on the word embedding and mapping stuff. If you want to know, my favorite idea though is,
Well, that was the follow-up question, so keep
my
going.
favorite idea is to use reinforcement learning. I don't know how much of you are familiar with that, but if you are, the idea is to take reinforcement learning and have it train on server errors or logs on your deployments, and then have it debug your deployments based on those logs. Where obviously it has a fail-safe of escalate to human, but then it can do a whole lot of monitoring and just stupid reboots on its own, and it learns from the system itself. I want to do that so bad.
Have you heard of Dynatrace?
No,
You should check it out.
there's always so many things to check out.
Have you used tools from any of the other cloud platforms?
I have used some AWS stuff.
Yeah.
How
How
do you
would
compare?
how would you see that, GCP really differentiates?
GCP has more APIs, and AutoML they have so many different AutoML options. It really allows you to use unstructured or semi-structured data better than what I've seen with AWS. I haven't dug that deep into any. My knowledge of AWS's offerings is about a year old. I really haven't dug into it since then. But Google's just moving so fast and providing so many different things on the AI front that I've just been super impressed.
I did some study, this was probably 2 years ago on some of the it was image to text, and at that time Google was probably about, it was like 97 to 87%. It was like 10% more accurate than the AWS.
So I can tell you what I've heard, and I'm not verifying this, but I've heard as far as models go,
Yeah.
you have Microsoft models and APIs, Google's, and then AWS. That's how they rank from not my experience. From
Just
what I've
in
heard.
terms of the accuracy.
Just in terms of the models and tools that they provide in accuracy, yes. But that has nothing to do with the rest of the offerings they hold and stability across it, right? Like,
Right.
there's so many more things that you think about when you're choosing what kind of toolkit to use. And like I said, at Weave, we're on GCP, so it's just been a no-brainer to use these tools, and they've been amazing.
I'll make one other comment about GCP. So you mentioned BigQuery, and increasingly Google is treating BigQuery as like the main hub for all of your structured data, and so it just integrates into all of their
They
products.
basically are trying to make it equivalent to Redshift for an enterprise level data warehouse. I've used Redshift. I thought Redshift was awesome. I haven't used BigQuery in that way, and that's my fault.
Well, and BigQuery's also got a lot of groups that compete with Athena as well. So it's kind of like this is everything you need in one box. Do it.
So yeah,
You said they used, you were doing some time series, storing time series data?
we were, yes.
Yeah.
But we were not super intentional about the methods we were storing in it. And so it made it really hard to kind of get insights from that data.
Okay.
I thought that Google had a specific tool for leveraging time series data, but I don't remember.
They recommend Bigtable for a lot of applications, but beyond that, I'm not sure.
Bigtable is more expensive than BigQuery.
Massive.
Yeah.
Anyway, I know but there are platforms and tools that are specifically for time series data because it is so valuable and also unique in its format. We have anything else? If not, we can jump to the raffle of the things.
Yeah, and I'm actually, Joe Reese and I are giving a talk in February. Was it in ML Utah?
Yep.
And we'll kind of build on these themes. So we're going to be talking about data pipeline foundation for machine learning engineering.
That'll be here.
And one of the themes will be that you should start by using managed tools like this before you do anything really sophisticated, because it's quick and easy, basically. Get things out the door really fast, very fast. So we'll try to build up on visual, right? We'll talk about that.
Yeah. Build on it. But that's here. It's the last Wednesday in February. We have every fourth Wednesday when we do the ML Utah meetups. And I try to get decent content. Usually I have a lot of people have commented on how good the content's been, and it's all been local. So we've got to have some really good speakers. Okay, so I have a raffle here. It's going based off of the RSVPs on Meetup. If you're not here, I refresh the page. How it works. Deepak. Alfred Kane. Kyler.
That's right.
I'm not eligible to win. I think that's one of the rules. Okay, we got one more. Cody Irwin.
I'm not eligible either.
Yeah, you're Google.
I'm Google.
Ineligible. Will Ferris.
Ferris also.
Cody Hall.
Oh,
Hey,
yeah.
nice.
Good job, guys. If you have any questions, I'll take them. If not, eat more pizza. Whatever. I'm getting off.
That's so good.
Yeah, you feeling light now?
All right, thank you.
Again. Man, back to back. What are we doing tomorrow?
Yeah, you made it. I'm so happy.
I've got issue production, so. Boulevard, street.